other forms, and now we are at the final stage, improper fractions. It seems quite long, but we are just like kind of repeating the same process over and over again. Okay, so for improper fractions, this occurs when the degree of the numerator, okay, degree of numerator is when the degree of the numerator is greater than or equal to the degree of denominator. So the first thing we are going to do is to perform polynomial division. Okay, so let's take a question, for example. We're going to solve two questions straightforward there. So let's take for a question, for example, we have 2x squared, okay, plus 3x plus 10 divided by x plus 1 and x plus 2. Now we will realize here that the denominator has a total of x squared. Okay, the highest power is x squared, and the highest power of the numerator is also x squared. Now here we see that they are equal in power, right? So all we just have to do is perform a polynomial division. So to perform a polynomial division, we open the numerator, the denominator rather. So you have 2x squared plus 3x plus 10 divided by x into x plus 2 plus 1 into x plus 2. So this will give us 2x squared plus 3x plus 10 divided by x squared plus 2x plus x plus 2. So this will give us 2x squared plus 3x plus 10 divided by x squared plus 3x plus 2. Now this will go back to polynomial division. Now if you have not watched the video on polynomial division, please kindly head back now and let's do justice on that. Now let's perform the division. Okay, that means we have our quotient. Remember, we have our quotient, we have our divisor, we have our dividend, and also we have our remainder. So our dividend is 2x squared plus 3x plus 10. That what we are dividing, and what we are dividing it with is our divisor. That's x squared plus 3x plus 2. So kindly go back and watch the video, okay, and so you get more emphasis on it. Now the first thing to do is to divide the first term of the dividend by the first term of the divisor. Okay, so when we divide that, we have 2x squared divided by x squared, and that will give us 2. Okay, and the next step is now to multiply this with the whole of the divisor. Okay, so that's 2 multiplied by x squared plus 3x plus 2, and when we do that, so we have x squared, 2 multiplied by x squared, we have 2x squared, 2 multiplied by 3x, we have 6x, and 2 multiplied by 2, and then we have 4. Okay, now the next thing to do is to subtract. Okay, so 2x squared minus 2x squared will give us 0, right? And 3x squared will be 0. 3x minus 6x will give us minus 3x. Okay, and plus 10 minus 4 will give us 6. Let me remove this. Okay, now we can now see that this is our remainder. Okay, this is our quotient, this is our dividend, and obviously this is our divisor. Now remember how we used to write back then in polynomial, this is dividend, sorry, that dividend is equal to quotient multiplied by divisor, okay, multiply plus remainder, sorry. Okay, so now our dividend, which is 2x squared plus 3x plus 10, and our quotient is 2, our divisor is x squared plus 3x plus 2, and plus our remainder, which is minus 3x plus 6. Now Let's divide both sides by our divisor. Okay, our divisor, so that's divide both sides by x squared plus 3x plus 2, and x squared plus 3x plus 2, and x squared plus 3x plus 2. So with this we have 2x squared plus 3x plus 10 divided by x squared plus 3x plus 2 will give us 2 plus minus 3x plus 6 divided by x squared plus 3x plus 2. Now let's go back a bit, and we will see how we arrive at x squared plus 3x plus 2 is the same thing as x plus 1 x plus 2. So now let's substitute x squared plus 3x plus 2. Okay, so 2x squared, okay, 2x squared plus 3 plus 10 divided by x plus 1 x plus 2 is equals to 2 plus minus 3x plus 6 divided by x plus 1 and x plus 2. So now this is the question we were given, okay, and we splitted it into partial fractions. But now when we splitted it, we saw that it was improper fraction, right? Because the degree of the numerator is it was equal to, or it was, and it can also be greater than the degree of the denominator. So we have to do polynomial division. So when we did that polynomial division, we arrived at 2 plus this, right? So this, now we can now resolve this into partial fractions. Okay, so now let's focus on minus 3x plus 6 divided by x plus 1 and x plus 2. Now in that case, we can now see that this is related to non-repeated and linear factors at the denominator. Okay, so we go back to our first video that we did as the part 1 and plus 2. Okay, and this will be a and this will be. Okay, so to solve this we just have to find the LCM like we always do, like we have been doing. X plus 1 x plus 2, and this will give me x plus 1 as well, and x plus 2. This will be a into x plus 2, and this will be a plus b into x plus 1. Now since the denominator are equivalent to each other, we can cancel them out. So this will be equivalent to a into x plus 2 plus b into x plus 1. Now this looks familiar, right? We can just easily use cover up method. Okay, to make this element here 0, we have to apply x is equals to minus 2, and to make this one 0, we have to apply x is equals to what? Minus 1. So let us put x, okay, put x to be equals to minus 2. So that's minus 3 into minus 2 plus 6 is equals to a into minus 2 plus 2 plus b into minus 2 plus 1. Okay, now this will turn to 0. We have minus 6 plus 6 plus 6 will be equals to b into minus 1. Okay, and then we have 12 is equals to minus b. So definitely our b is equals to minus 12. Now we can also put x to be equals to minus 1. Okay, from here, from this equation, okay, we apply this here, and now we also apply this here. So that's minus 3 into minus 1 plus 6 is equals to a into minus 1 plus 2 plus b into minus 1 plus 1. Now minus 1 plus 1 will be 0. Okay, so everything here comes to 0. So we have 6, no, 3 plus 6 is equals to a into 1. So a is equal to 9. Okay, now that we have a to be equals to 9 and b is equals to minus 12, then we go back to this place like we used to do. So I have that minus 3x plus 6 divided by x plus 1. Okay, and x plus 2 will be equals to a over x plus 1 plus b over x plus 2. Now with That's done. We now substitute our value for a, and we also substitute our value for b, and our a is 9, and our b is minus 12 divided by x plus 2. So with that done, we have 9 over x plus 1 minus 12 over x plus 2. Now this is equal to 3x plus 6 divided by x plus 1 and x plus 2. Now the question actually was not this. Okay, this is the actual question. Okay, this is the actual question, and it was now splitted down forward into this. Okay, so here is what we are going to. So we can rewrite the question, and we will add our remainder of 2 to the equation. So recall, let's do a bit of recalling that the question, which is 2x squared plus 3x plus 10 divided by x plus 1 and x plus 2, okay, like we have here, is equal to 2 plus is equal to 2 plus minus 3x plus 6 divided by x plus 1 x plus 2. Okay, and then we substitute our value for minus 3x plus 6 into this, so we have 2 plus 9 over x plus 1 minus 12 over x plus 2. Now this is now our final answer. Okay, so what is changing here is that we just have to perform our polynomial division first. Okay, so I want to lay emphasis on it again that please go back, and if you have not watched the video on polynomial division, kindly and urge yourself to watch the video for a better understanding of polynomial division. Okay, so with that done, we will take another example, and this will be the last example for this video. And the question says it's number 2. Resolve 3x raised to power 3 plus 22x squared plus 38x plus 7 divided by x minus 1 and x plus 3. Now we can see that the highest power of the denominator is x raised to power 3, and the combined power of the denominator is x squared. Okay, when this multiplies this, we'll have x squared. Okay, now we can see that the denominator, the degree of the denominator is higher than the degree of the degree of the numerator is higher than the degree of the denominator. So definitely we have to perform polynomial division. Okay, a long process. So after that is done, so we just have to open the denominator. Okay, so let's open the denominator. So we have 3x cubed plus 22x squared plus 38x plus 7. If we open up the denominator, we will have x squared plus 2x minus 3. Okay, now let's perform polynomial division. Sorry, let's perform polynomial division. So our dividend is 3x raised to power 3 plus 22x squared plus 38x plus 7, and our divisor is x squared plus 2x minus 3. Okay, now as usual, the first thing to do is to divide the first term of the dividend, divide it by the first term of the divisor. So we are saying now we have 3x cubed divided by x squared, so we left with 3x there, and then we multiply our answer here, 3x multiplied by the whole of the divisor. Okay, with that done, we have 3x multiplied by 2x. Okay, and that will give us 3x cubed. We also have 3x multiplied by the first one is 3x multiplied by x squared, so we have 3x cubed. The next one is 3x multiplied by 2x, so we have 6x squared. And last one is, so we have 3x multiplied by minus 3, and that will give us minus 9x. Okay, so after that is done, we subtract. Okay, so 3x cubed minus 3x cubed give us 0. 22x squared minus 6x, 22x squared minus 6x squared will give us 16x squared. Okay, and 38x minus 9x. Okay, so there are two negative signs there, so it give us those negative times negative give us positive. So 38 minus 9x will be 38x plus 9x, that will give us 47x. So you can drag this one downward further, so give us plus 7. Now this first term here is still divisible, okay, by the first term of the divisor, so we can perform the process again. Okay, so when we divide that, okay, we will be having 16x squared divided by x squared, and that will give us plus 16. So after that is done, we multiply the whole of plus 16 with the whole of the divisor, then we perform our subtraction again. So that means we are saying plus 16 multiplied by x squared will give us 16x squared, plus 16 multiplied by 2x will give us 32x, and plus 16 multiplied by minus 3 will give us minus 48. Okay, then we now make our subtraction. Now with that done, we now subtract our 16x squared minus 16x squared as 0. 47x minus 32x will give us 15x, and 7 minus 48 that's 7 plus 48 will give us 55. So at the end of it all, we would be having this to be our dividend, okay, this to be our divisor, this to be our quotient, and this to be our remainder. All right, so with that done, and we remember that our dividend, okay, our dividend is equal to the quotient multiplied by the divisor, okay, plus the remainder. Right, so since our dividend is 3x cube is our dividend here, 3x cube plus 22x squared plus 38x plus 7, and our quotient is 3x plus 16 multiplied by our divisor, okay, x squared plus 2x minus 3 plus our remainder, which is this 15x plus 55. Alright, with that done, we want to divide them all through by our divisor. So that's x squared plus 2x minus 3 divided by x squared plus 2x minus 3 divided by x squared plus 2x minus 3. Now we'll have 3x cubed plus 2x squared plus 38x plus 7 divided by x squared plus 2x minus 3, okay, will be equals to this. We cancel out this 3x plus 16 plus 15x plus 55 divided by x squared plus 2x minus 3. Now something is common, x squared plus 2x minus 3, x squared plus 2x minus 3. Okay, now how do we go about that? We remember from the beginning that x squared plus 2x minus 3 is the same thing as x minus 1 and x plus 3. So we can now write again that 3x cubed plus 2x squared plus 38x plus 7, and instead of writing x squared plus 2x minus 3, we will write x minus 1 x plus 3. Okay, so we have x minus 1 and x plus 3. So this will give us 3x plus 16 plus 15x plus 55 divided by x minus 1 and x plus 3. Alright, so when that is done, we can now see that this, okay, this can now be further divided. using partial fractions. Okay, so we can see now that we have linear and linear denominators, which will be quite easy, just like the first one. Of course, you can have non-linear factors at the denominator, okay, even after dividing. But I might say it's actually very rare for that to happen in improper fractions. So with that done, so we have 15x plus 55 divided by x minus 1 and x plus 3. Okay, now to split this, we know that this is x minus 1 and this will be x plus 3 and this will be a and this will be b. All right, so let me take a bit of let me say 2 minutes. Let's see if we can solve the values for a and the values for b. Now, so we take LCM. Okay, 15x plus 55. You can solve ahead of time to get the values of a and b. Okay, this is x minus 1. This is what we have been doing since first video. And x plus 3 and x plus 3 plus b into x minus 1. So we have 15x plus 55 will be equals to a into x plus 3 plus b into x minus 1. Right? So we can use cover up method here instead of using you can use cover up method instead of using comparing coefficients. Okay, so here we can put x to be equals to minus 3. Okay, so that means 15 into minus 3 plus 55 is equal to a into minus 3 plus 3 plus b into minus 3 minus 1. So this will turn into 0. So this in total give us 10. Okay, is equal to b into minus 4. So our b will be equals to 10 divided by minus 4, which means that our b is equal to minus 5 over 2. Okay? So again, I can also put my x to be equals to 1. So I have 15 into 1 plus 55 is equals to a into 1 plus 3 plus b into 1 minus 1. This will turn this to 0, and at the end we'll have 70. That's 15 plus 55 is 70, and then we have 4a. So my a will be 70 divided by 4. Okay, and that will give us 35. A to be 35 over 2. Alright, so then we go back and repeat what we have here. Substitute our values for a, and also we substitute our values for b. So that means we are saying the question says 15 plus 5 plus 55, 15x plus 55 divided by x, okay, x minus 1 and x plus 3, x minus 1 and x plus 3 will be equal to a over x minus 1, right, plus b over x plus 3, and our a is 35 over 2, and x minus 1 plus b, which is minus 5 over 2, and divided by x plus 3. So with that done, we can simplify further and say this will give us 35, okay, over 2 into x minus 1 minus, okay, minus 5 over 2 into x plus 3. Now this is equal to 15x plus 55 divided by x minus 1 and x plus 3. Now when we have this done, we can now substitute it back into what we have here. Okay, so let's repeat everything we have in this box, right? and then when we repeat it, okay, the question 3x squared plus 2x squared plus 38x plus 7. Then we now substitute our value for this. We have 3x squared cube plus 22x squared plus 38x plus 7 divided by x minus 1, x plus 3 is equals to 3x plus 16 plus 15x plus 55 divided by x plus 1, x minus 1, and x plus 3. Now, we can substitute the value of this for this. Okay, so our answer will be 3x plus 16 plus 35. So anyway, I see this guy, I substitute with this guy. Okay, 5 plus 2 into x minus 1 minus 5 into 2 into x plus 3. So then we'll have our final answer. Okay, so improper fractions, the first thing to do as usual is to multiply out your denominator, and after we multiply out our denominator, then we proceed further to do our long division method of polynomials. And after our long division method, then we then split the remaining side into partial fractions, which can be linear factors or non-linear factors, as the case may be. Then you return it back. Okay, you return it back into the equation that we've generated from the beginning. Okay, so it is very, very important. Okay, so please, if you're having troubles running through the last two categories, that means repeated linear or repeated non-linear, please you can is advisable to go back to the first two. Okay, there's non-repeated non-linear and non-repeated linear factors. So with that, we'll be able to have a crisp understanding, because those videos were extensively long to ensure that understanding is established. Alright, so this brings us to the end of partial fractions. Shalom.